provide some other thoughts and insights that will pass as well. Very briefly talk about some of the challenges, but then the opportunities that are out there, and we'll build on some of the remarks that both David and Mark have made. And then talk about some of the solutions that we see coming down the pike, both in very specific ways, such as building efficiency, and then more broadly, how one might put together an integrated program. Because in essence, what we're going to say today is we think that by having a forward-looking program and making sure it's well integrated, you're going to get the maximum benefit for the amount of money that you may spend or save as you go along the way. So in terms of the forces at work, there are really many forces at play right now in the energy industry. And I think it's fair to say that there's as much potential churn and turmoil as these industries have ever faced in the history of their existence. I'm speaking primarily around oil, coal, and natural gas use, primarily going into electricity and then into heating and industrial processes. And so what you see here is a number of different forces that one needs to take into account as you're trying to build a plan. And these range from things like regulation that may be imposed at the national level to different environmental concerns or new technologies that are coming out almost weekly, if not yearly. And so I think there's a lot of exciting but also daunting challenges are out there. Let me just illuminate a few of those. In this next slide, what you see here on the y-axis is the cost per million BTU, and on the x-axis is time. And what we're seeing is we've seen a long period of quite stable pricing for the most part. The oil obviously has been very dynamic over the decades. But it is likely in many parts of the country, whether or not this becomes true in Nebraska, I think in many respects depends on the program they put in place, but there are escalating fuel prices. And so the work that we're doing in Texas, the work that we're doing out on the East Coast, telling us that a number of utilities, after having put off capital expenditures for a number of years, are facing the need to raise rates. And so that's a real economic impact there. In this next slide, I won't go through this in detail, but this is some of the legislation that's on the table nationally that can have a dramatic impact on the way people think about cost of carbon, the value of energy efficiency, and the value of alternative technologies. And I think it was mentioned by some of the other speakers here, it would be nice to be very proactive and ahead of the curve on this rather than trying to react to what's going on at the national level. And certainly my relatives who live just outside of Valentine, Nebraska would, so I very much agree with that approach, especially since they are in north central Nebraska where there is an abundance of wind and they're wondering how they can use that wind which seems to blow continuously to them in a more sort of sustainable, reliable way for themselves. This is a bit of a laundry list here, but I think it's quite an important one. There are a lot of things going on in the energy space right now that one needs to think about. For example, number one, plug loads could flatten. By plug loads, I mean plasma TVs, computers, all the electronic gizmos that we have in our houses today. We believe that there may continue to be increasing plug load demands, but in fact, there is so much headroom to make these things more efficient that may not turn out to be the case. In fact, as we see convergence of technologies such as computers, cell phones, video equipment, it may well be that there's a decrease. So recent work we did in data centers, which suggests this is definitely the case. The work we did in the design data center last year showed, and that facility is going to open in 3 months, that you could remove 80% of the energy per unit of service. So we may actually be seeing right now the apex of the use of electrical power per unit of service in the IT industry. I think Marcelo brought up a really interesting idea about thinking about perspective and how change happens. If you think about solar PV, so that's photovoltaics, which OPPE is trying to test out, there are dramatic changes going on right now. We're seeing costs drop dramatically, and we're seeing new technologies come on the scene every few months. And so if we think 20 years out, a lot could change in that time. It is possible that solar hydrogen could come on the scene in the next 20 years, and that would affect the variability issue and the ability to store energy. It could be, I'm not saying it will, but it could be that fuel cells actually become economic at some point, and then you have combined heat and power systems that are actually at the residential level. We do know for a fact, and I'll show you some examples, that building designs and retrofits could very much dampen electrical demand, and we've seen real-world cases now that we've worked on, those numbers are on the order of 20 to 50% reductions. And then finally, one that I'm sure the utility system work thinks about a lot is you think about electric vehicles and the chance that they may become a major player and user of electricity over the next 20 years. That is both a very interesting, alluring thing for utility because it's an area to grow in and would dramatically reduce CO2 per mile traveled. But it's also daunting because, as was pointed out by Mark, the integration of electric vehicles into the grid is no simple thing to do. So those are some of the disruptive pieces there. Let me pause for a moment and see if there are any questions. I guess we'll take questions later, so I'll just keep on moving on along then. Let me just talk about two sides about the challenges and opportunities. So from our perspective, there are a lot of forces at work. It is not the case that all of those will come true in the next 20 years, but ask yourself if you think that none of them will become true in the next 20 years. Because if any one of them becomes true, of the ones I've mentioned, it's going to have a very disruptive effect on our utility systems, and it could have a dramatic effect on how we operate our lives, how we interact, and how we work together. So it's really not a question of they all need to become true and that we have a problem on our hands. In fact, if a small subset of them become true over time, it will fundamentally challenge the roots of the way we use resources, the way we actually have business models for utilities. And so we think that it is worth taking the time to think very carefully about them and the impact they may have on us. So in terms of the challenge, I'm going to focus mostly on the electrical system here rather than the gas system. But as many of you know, the current electrical system is something that Thomas Edison would recognize as electrical wires and transformers and generation capacity. And in fact, the electricity flows out of these central facilities out to homes and businesses. And as was pointed out by Mark, you don't actually know how much you're using at any single given moment, and often you don't know how much it costs you. And so when you think about the electrical system, unlike the communication system in the U.S., it really hasn't moved that much, and there's a lot of headroom to think about what one could do. It's also fair to say, I think this was already pointed out, that we have probably underinvested in the system over time, and so large capital investments will be required in the next decades. And I think that should very much ask the question then, well, what do we really want to invest in? Things that we're already certain about and we feel comfortable with, but may become white elephants over time, or what is the next generation that may come back down the pipe? And no doubt a balanced approach will be required, but I think it's really important to think about that set of investments, because if you're going to invest in the units that's going to last somewhere between 30 and 60 years, it's critical to try to make the right set decision and have the right portfolio. And then finally, I think as mentioned, the system is brittle. It is not just aging, but in fact open to both man-made and natural disasters. As in some of the work that I've done with the Air Force, one of the biggest concerns they have is about the fragility of the internet, the grid system to cyber attack. And with very large pieces of equipment that are moving at high speeds, it is possible to do damage to the system that can take weeks to months to repair. And so that is a critical thing to think about and has bearing on the way you think about distributed generation. So that's the current view, or at least parts of the electrical system. Again, thinking more about electricity rather than gas now, but they're quite interrelated when we start thinking about heating systems in the home. The good news is there are a lot of technologies out here. These are in cartoon form, and I'll show them as real pictures later. But many of the elements we need are out there to help us think about a new system. And I show in this picture here things like windmills and solar panels and homes that are using sun and cars that are plugged in. These all exist today. And the challenge, I think, as was laid out by Mark, is we know how to run central generating plants and run them very reliably. We know how to get that electricity to our homes. I mean, how many people really have problems turning on the lights? Well, occasionally there's an electrical storm, you're out for 2 hours, but in my 49 years, it's been very occasional. So it's actually quite a good system. If you start talking about knitting together technologies that are variable, such as wind and sun, combining that with electric vehicles, which may either be drawing in electricity or putting electricity back out into the grid. If you think about distributed generation like cogeneration, you have to have a much more sophisticated approach. And so I think the good news, bad news story here is the good news is many of these technologies have been developed and are available to us and are being tested, as you heard from Mark and Dave. They have not yet been demonstrated to be able to be knitted together into a system that is reliably meet our demand every minute of the day. And that's actually the focus of a lot of Rocky Mountain Institute's research right now. Let me finish up here and just talking about some solutions. And there's not a full system solution here. That's not really the purpose of the day. It's just to give people a flavor of the fact that there are many things that are happening. It's a very exciting time. And as the city of Omaha and other cities around the nation proactively move forward, I think we can create new systems that build communities, build businesses, are economically good for us, and at the same time husband our resources in a responsible way. So a couple of examples, and this first example is really about losses, and it reiterates in graphical form the efficiency message that both Dave and Mark had. And what you have here on the left-hand side is a coal-fired power plant, and it converts the energy in coal into electricity. And in doing so, it roughly loses around 70% of the energy content in that coal. And therefore, a lot of that heat just goes up the stack, as it were. You receive a cooling tower. That electricity is then transmitted through the grid, converted into a motor, which is then moving some kind of pulley, which is then moving a pump, which is then moving fluid through a piping system, which is then throttled down, and eventually doing real work on the right-hand side. And of the 100 units of energy that went in, about 9 or 10 are actually used for the thing you really care about, like moving some liquid. And so there's a great compounding loss as you go from the left side of this chart to the right side. But think about it the other way, and think about the message that Dave and Mark have given you, which is it's all about efficiency. It's a very powerful opportunity. Well, in fact, it's right. So if you took those 9.5 units and you reduce the need for that fluid, let's say it's a cold fluid that is cooling a home or industrial process or a commercial building, and you've insulated the building, or you've put in better windows, or you've reduced the heat load due to your inefficient lighting system. Now imagine those 9.5 units dropping to 7 units. So you reduce by 2.5 units, roughly 30%, the amount of energy you need for the thing that you're interested in. Well, take those compounding losses and work your way back up the chain, and what you're going to find is rather than need 100 units of input energy, you're only going to need 7. And that's why efficiency is such an important and highly leveraged tool to use for reducing the impact of resources on our environment and our cost to our communities. So in a nutshell, there's all these losses that happen before you actually do the thing you want. If you need less of that thing because you've taken other actions such as insulation, then those compounding losses then turn into compounding gains for you. And that is, in essence why efficiency is so important. Here's another fact for you, and you can look this up on our website if you want. We recently did some work on energy productivity. So on the y-axis here, we have GDP, so economic output per kilowatt hour. So this combines what we care about in terms of economic power of our city or our state with the use of electricity. And what we found is by looking across the nation and understanding what the top 10 states would do, and that's over on the right-hand side of the red bar, that generally speaking, there's about $6.3 of GDP generated per kilowatt hour in the top 10 states in the nation. So that's the top 20% of our nation. When we take Nebraska and we start on the left-hand side with the raw numbers, which is about 2.6, well below the national average, and we then adjust for the fact that Nebraska has varying amounts of commercial versus industrial work, business, that it has varying amounts of heavy industry, and we normalize for weather, we come with an adjusted number, which is up more like 2.8. Whether or not that number is 2.8 or 3 doesn't really matter. It's well below the national average. And this isn't anything disparaging about Nebraska. In fact, I look at it very differently. The gap that we see of about $3.50 GDP per kilowatt hour means that in Nebraska you're sitting on an enormous opportunity to use efficiency because these gaps primarily arise from efficiency, an enormous opportunity to drive energy productivity, which means more economic output per kilowatt hour in, which to me is a very good news story for the state. The question is, how do you capture it? In the next slide, here's an example of one way to capture it, and it refers to a paradigm that we call tunneling through the cost barrier, and it really boils down to this. This is a building in Grand Forks, and a bunch more money was spent on windows, daylighting, insulation, and lighting. Those all dramatically reduced the heat load on the building, which allowed the HVAC system, heating, ventilation, and air conditioning, to be dramatically downsized, and that saved $160,000. So there was a net first cost reduction of about $36,000. But more importantly, by being a much more efficient building, it's generating about $75,000 a year in net savings on energy. So there's a really nice synergy here which says spend more money in some places, which look uneconomic, save money in other places, and overall bring the operating expense of your building down dramatically. And that's one of the things you can do to help close the efficiency gap. In this next slide, which refers to some recent work we did with the Empire State Building, there's a great deal of detail if you go onto the website for the Empire State Building, search for it on the web. But basically, we worked for a number of months with the owners there, Joan Langs LaSalle, which is a very large property management company, and Johnson Controls, which does building retrofits. And we were able to demonstrate that we could reduce the energy use in a retrofit situation, not only build a retrofit of the Empire State Building, by 38%. And so by combining these measures together, an innovative approach, basically able to take out a building that's pre-World War II, 38% of the costs. It's going to be about a 3.5-year payback and save a lot of CO2 over the next 25 years. So there's an example there of what you can do with new buildings, an example of what you can do with retrofitting older buildings. The economics were interesting. I'll show you. This is for people who kind of like financials. But this is looking at the curve of what the net present value is. In other words, the real value of this project, the Empire State Building, and what the effect was as you try to capture and save more and more carbon dioxide, which is one of the goals of this work, was to focus on climate change. And as you can see, depending on how much carbon dioxide you want to capture, it changes the value of the project. But if you think about it from a community point of view, and the fact that you're going to reduce energy use and CO2 at the same time, for example, for most buildings that are run and operated by municipalities, you can easily access most of the CO2 savings, which is the x-axis here, and still end up in a net break-even point of view or even positive point of view. So what it's telling you is the economics work out quite well. You just have to do this in the right order, with the right kind of integrated design. Finally, the last couple of slides here, I told you I was going to show you some of those technologies that were cartoons before real pictures. And what we're doing here at RMI, we're working with other states, communities, utilities, is how do you get all these technologies together in a way that will actually meet demand on a second-by-second, minute-by-minute basis. We've built models to do this, and we're actually starting to test out the work in the field with other large utilities in the United States. One thing I haven't mentioned a lot, and I think it's quite important, in the center of this diagram, it says intelligent grid integration. This is a term that's bandied about a lot in the United States under the term of smart grid, typically. Smart grid is more or less how do you tie these things together in the information age so they can talk to each other in real time, be dispatched appropriately, or turned down at the appropriate time. And what you'll see in these technologies is things like demand response has to do with air conditioning and how we can modulate that, as Mark pointed out, and that would be done through a smart grid approach. If we're going to plug in electric vehicles, we want to make sure they charge at night when nuclear plant isn't running at high capacity. We can use that excess capacity inexpensively. If we have renewable energy and it starts to come on, we get a lot of wind coming through the state, well then we want to charge up things like electric vehicles during that time and not have them charging when the wind isn't blowing. So there is a very alluring potential out there of getting these technologies together, and if you're taking a 20-year view, I don't think one can ignore the fact that they will all mature dramatically over the next 20 years, and we certainly have at least the moving parts we need to potentially create a very low carbon, very robust, very cost-effective system that may not follow the conventional approach that we've taken in the past. A couple of other things to touch on. We think energy efficiency can create a lot of jobs. These pictures here, I don't know if they show that, but there are places that do need to be fixed up. And in fact, you can't outsource jobs that have to do with retrofits, rebuilding, and things like that. They have to happen here in this country. And I think there's a really large potential to get people skilled at the community college level, university level, to think about how do you start entrepreneurial businesses really to do energy retrofits efficiently, economically, and with a large workforce that's required to do that work. This is a quote from Johnson Controls that does a lot of energy retrofit, and basically their perspective is, given the stimulus money coming out of Washington, given the need in the nation, and given the large paybacks from efficiency that we mentioned from Mark and Dave, there is not nearly enough qualified people out there to help do this work. And so it's something to think about in the city of Omaha. Here's a chart that shows you about global wind power deployment projections, and you can see they're large and growing depending on what scenarios you think about. Nebraska is a very wealthy state when it comes to wind and solar, as has been pointed out already. And obviously people there are thinking already about what to do in terms of taking advantage of that capacity, that natural resource you have. I think it's also worth thinking about what other job types of creation you can create, whether it's leading edge technologies or integration technologies or whatever else is going to be required around the nation. And finally, I'll just finish up by reiterating what I said earlier, which is we really believe you need to develop an integrated strategy, that doing things in any kind of piecemeal way will capture real value, but you need to have the 20-year view. You need to understand where there may be synergistic effects as you start to use more energy efficiency. How could that potentially lower the issues that arise from fluctuating renewables? How could you develop jobs and entrepreneurial business that go along and complement the actual energy efficiency and resource efficiency you're going to try to carry out? So I'm not going to go through this list in detail, but there are methodologies out there that you can utilize, and we would encourage you to utilize, to help you put together a very systematic, integrated strategy that is founded on solid economics. Give you a chance to think about different scenarios depending on what might unfold in the ensuing years as we think about what the price of solar and wind might be, what kind of carbon costs might be incurred at the national level and imposed on the states, and what is going on in the rest of the nation. So without further ado, I think I'll stop there.
Of our meeting here, and thinking about all that we've heard and some of the things that Steve just shared, you kind of get stuck in the situation of why are we doing more? But clearly these are complex problems that have been 100 years in the making, and it's very exciting to see the opportunities that are underway. And I think there's a lot of change, positive change that can happen. So actually, for me personally,